Hi, my name is Jeremy Argueta. I'm with the Positive Augmented Research and Development Lab, and today I'll be going over our most recent work, which is our observational study on the Europa simulation. In 2038, there's a proposed mission to send a lander to one of Jupiter's moons, being Europa. The lander is equipped with an autonomous system so it can make decisions on its own, since the team on Earth is too far away to upload decisions for it. The objective of the simulation is to see how JPL personnel would interact with the autonomous system. However, my team and we had an objective to identify mechanisms pertaining to trust while these negotiations and planning processes were happening within the Europa simulation. Not only that, we were trying to accumulate and organize ethnographic data while trying to capture that science intent to assist the autonomous system with these human interactions. Our approach was to use Airtables to record any quotes that we found to be that science intent that we were mentioning earlier. We also used timers to record verbal participation. And the participants that were involved were 20 plus JPL and non-JPL personnel, which included departments from operations, engineers, and scientists. The quotes were identified with a theoretical framework that my team and I collaborated with JPL. The paper is called Human-Computer Interaction Globe, Examining Operational Trust and Intention Towards Mars Autonomous Systems, which again focuses on what we think science intent is. And we call those science intent function performed, as shown as the diagram above. So any quote that we find within the simulation, we would tag it for one of the functions that is listed above. And then for verbal participation, anytime a participant spoke within the simulation, we would start that timer. And as soon as they stopped speaking, we would stop that timer and then start another timer for the next participant that started speaking. Thank you so much for listening to this overview of our work. I'd like to thank my team members, and I hope you have a great day.
Hello, my name is Jaime Garcia, and together with Sarah Ellinger, we are the ARCS Research Fellow who will be presenting our projects, Designing for Accessibility, Analysis of Interaction Barrier Team. We also have Samir Wasim as an ARC Associate and Dr. Lee Liu as our CSUN Advisor. A bit of background about accessibility. The idea of accessibility is to make the environment and tools we use around us usable by anyone, regardless of a person's background. In user-centered design, it is important to empathize with your user when developing products and services. Learning as much as we can from people with disability is ideal to make the environment and tools more inclusive. These video blogs provide insight with how people with disability experience their daily lives. People with disability offer a different perspective. When people with disabilities are constantly bringing up the same usability problems, then it's worth making special note of these issues. Unfortunately, it is impractical to go through thousands of hours of video blogs, and Sarah can speak more about the research approach and methodology.
Thank you. Our project is a quantitative analysis of curated text data taken from social media vlogs created by a focus group of community-dwelling people with diverse disabilities. Our study group, from which we are creating a database from, are primarily from the United States, but also from other English-speaking countries. Our focus group consists of hundreds of content creators documenting their experiences in their homes, communities, workplaces, and other social participation settings. The intended outcome measures of our research are the environmental barriers and supports to individual participation. We are programmatically gathering user accounts with vlog data through the use of public APIs and are crowdsourcing a manual validation check on our data cleansing activities. Our data ingestion and processing pipeline is shown in the top diagram here, where we first crawl vlog data, then process it and load it in a form that we can readily analyze. That data is then analyzed visually for any trends in disability types or common accessibility issues that individuals experience. From there, that data will be fed into a language understanding model to appropriately and accurately detect any accessibility issues that users vocalized in their vlogs. From the resulting data, we will evaluate any existing gaps in process design or product design or any potential for future design. We thank you for your time and attention and hope you've enjoyed our presentation.
Hello, everyone. My name is Kendall Tucker. And I'm Michaela Langlois, and we are fellows on the project Team Culture and Communication at NASA's JPL, in collaboration with faculty at CSUN and Cal State LA employees at JPL and our ARCS associates.
Hi, I'm Kayla Hoy. I'm one of the ARCS associates.
Hi, I'm Brianna Neely.
Who are with us today, as well as Anne Margaret Price and Danielle Contreras. We seek to understand how the culture within JPL shapes collaboration within and between teams.
This is the third year of this project, and we hope to expand on research done by previous students. The first year of this project discovered a phenomenon within JPL called hero culture, which we define as a culture that values those that solve problems that arise during team projects that are often the result of poor planning in the early stages. Teams that do plan adequately and therefore don't face the same late-stage issues often do not get the same recognition as those with heroes that save the day. The second year of this project expanded on the first team's research by focusing on the impact of identity on team communication, including factors like hero culture. They found that both individual identities and team identities impacted communication. Different teams encouraged different types of communication, while an individual's personality, gender, race, sexuality, and cultural background impacted their own communication style.
Our team wants to expand on this research by examining how identity impacts hero culture. In preliminary research, we found that some teams experience hero culture while others do not. We want to understand what about teams' identity encourages or disencourages hero culture. We also wonder if an individual's background and life experiences impact their participation in hero culture behaviors. As a multidisciplinary team, we seek to use methods that utilize our varied skill sets. Suzanne Scheld, the CSUN co-investigator on this project, along with myself and other associates, are anthropologists. So we plan to use core anthropological methods such as participant observation, semi-structured interviews, and focus groups to gather qualitative data on the experiences of employees and teams at JPL. Monica Sheriff, a CSULA collaborator, has a background in business and quantitative research and will help us to develop surveys to understand the day-to-day communication between employees.
Using this data, we hope to develop a system of best practices for teams to better plan and communicate to create better team culture at JPL.
Hello, my name is Katia Yanes, and I am an undergrad geology student at CSUN.
Hello, my name is Chantal Perez, and I'm a computer science student at CSUN.
Our project is Sea Surface Teleconnections with Coastal Southern California. We're working in collaboration with JPL. Our team leader is Joel Roberts, data visualization developer. We're also working with Dr. Latha Bascaran, geospatial scientist, and Dr. Jorge Vasquez, oceanographer. Our faculty advisor is Dr. Mario Giraldo, a seasoned professor of environmental remote sensing. We will be investigating a teleconnection between ocean data and terrestrial processes, such as the sea surface temperature anomalies and soil moisture. This type of data is of great importance to the Southern California community. We will be utilizing the data from the Physical Oceanography Distributed Active Archive Center, also known as PODAC, and we want to facilitate access to the PODAC website to empower our communities.
We will be using deep learning, which is a subset of machine learning to investigate connections, patterns, and trends in data sets collected to help anticipate future events. We will also be creating data visualizations like story map and mapping and using GIST tools with design software such as Blender to connect and inform and bring awareness in ways that can be understood by our communities.
We're excited about the opportunity to work on this project and to help our community. Thank you.
Refuse all systems as such White House. Prototypes is that the systems
Hi, my name is Jessica Frederick. I am team captain of the Systems Engineering Research Laboratory, Robotics Senior Design in Mechanical Engineering, and a Robotics Research Fellow at the CSUN Autonomy Research Center for STEM. In emergency situations, search and rescue operations can greatly benefit from the assistance of robots. Sending robots into a collapsed or burning building can greatly reduce the risk of harm to personnel and expedite rescue efforts to save lives of those trapped inside. This research project is motivated by the NASA JPL Puffer and Cadre rovers that are used in space exploration, where the rugged terrain and inhospitable environments are an analogy to disaster regions. The Compact Autonomous Exploratory Search and Rescue Rover, or CSER, is a portable, easily deployable robot that will be capable of navigating indoor and outdoor urban environments, autonomously or as part of a human-robot team. The storyboard illustrated here demonstrates our expected use case scenario for deployment in a collapsed building. Some of the key concepts of CSER, which is shown in the exploded view of our 3D CAD model, are the chassis, deformable airless tires, camera, hazard sensors, and tail. CSER is designed to be compact, withstand an impact from a fall, be water and dust resistant, and be easily dismantled for repair. The outer 3D printed shell of the rover is a sandwich case design to prevent liquids from entering. The rover has 2 front cameras to maintain a wide field of view, even if the rover is flipped upside down. An aluminum skeletal structure, which sits within the 3D printed shell, is used to improve the rover's rigidity. To improve impact resistance during a fall, we implemented an airless tire design that will deform to reduce the impact force the rover will experience. The tire will be manufactured using flexible 3D printed filament with custom spoke design. We developed the electronic systems with batteries, 2 single-board computers, and a pair of DC motors for the drive system. Gas and temperature sensors are used for environmental hazard detection. Video depth cameras are used to see and map the environment. CSER's software systems are developed with a robot operating system, or ROS, on Linux, with an NVIDIA Jetson Nano for autonomy, navigation, mapping, and image recognition features. In conclusion, ongoing development includes manufacturing, implementation of object detection, path planning, and testing.
Thank you.
Hello, my name is Ran. I'm the principal investigator of the Spring Plantation project.
Hello, my name is Shui Huang, and I am the co-investigator in this project.
In the next few minutes, I will briefly discuss about the general idea of this research. Based on the data we collected online, we found out there are 1 million people suffer from various degrees of bone losses due to accidents or bone diseases, which necessitate the needs of development of bone regeneration technology. The most commonly used biomaterial in bone regeneration is titanium, which is well known as its good biocompatibility. However, there are still some limitations, such as the cytotoxicity of other metallic elements in titanium alloy. The body can have immune response to it, which may lead to inflammation. Also, the bulk metal implants lack of desire, osteoinduction, and osteoconduction, and can cause stress shielding, which will influence the connection between the bone and implants, eventually would lead to implant loosening. Additionally, metal implants will release metallic ions to surrounding tissue that can affect long-term health, and the surface of non-treated implants have chances to cause infection from microbial foam growth. The main objective of this proposed research is to design a porous titanium scaffolds, investigate the osteogenic and antibacterial biomaterial that will be coated to the implants to optimize biocompatibility, augment the rate of cell proliferation, improve the osseointegration, and to gain the antibacterial properties for effective bone healing. How are we going to approach this objective? We are going to use rhinosaurs to CAD model the porous titanium scaffolds and additively manufacture these scaffolds by using rhinoshell metal 3D printer. Simultaneously, we are going to synthesize the hydroxyapatite and serum hydroxyapatite by suspension precipitation method. From this method, we will get a product of hydroxyapatite powder material. Then we will use sintering technique to transform powder material into solid material that can be used with E-beam evaporator to coat the scaffolds we manufactured. E-beam evaporator has electron beam sources that will vaporize the solid material in vapor form. These vaporized molecules can go through the pores and attach onto the surfaces of the scaffolds. The cooler system will cool the molecules down to form a thin layer of coating. Then we are going to anneal the coated scaffold at 300 degrees Celsius in a furnace to restore the crystalline structure of hydroxyapatite and serum hydroxyapatite for biofunctionality. After that, we will conduct 2 in vitro studies with which we will seed the bone cells into the scaffolds in a mimic human body environment, and conduct the antibacterial study to directly contact the bacteria to our biomaterials. The table shown below illustrates the summary of the research approach. Thank you.
Hi, welcome everyone, and thanks for having us. We are the Moral Compass team, and the title of our poster is Ethics in Increasingly Autonomous Systems, also known as AIS. Our NASA-funded research is about formulating a moral compass for increasingly autonomous systems. Our research team encompasses fellows and associates covering respective disciplines. I am Christina Romero, and I am a fellow.
I am Michelle Misore, and I am a fellow.
I am John Crane, and I'm an associate.
We acknowledge that artificial intelligence is an objective due to coded biases and machine learning from algorithmic data. Therefore, we need to recognize the implications of artificial intelligence and create an ethical model to guide decision-making in increasingly autonomous systems to minimize inequity.
Our research takes an interdisciplinary approach by drawing upon multiple disciplines and has a grounding in ethnic studies. Applying a power reflexivity lens, we are guided by the following research questions. Whose ethics morals are reflected in the research question and in the design of an autonomous system? Who benefits from and who pays for these technological advancements and their unintended negative impacts? What technological advancements can be harnessed to decrease the existing inequities or at least not amplify them? What strategies or tactics can be used to empower people to better control our lives, lessen social inequities, and reconnect our values to our being and doing in a world that is technologically enhanced but not technologically restricted and defined? What methodologies do we employ for the progression towards ethical governance of AIS? What are some ways AIS can be regulated? Who and what government bodies will be in charge of regulation and compliance enforcement? Using literature review works on ethics and automation, we synthesize information to create a more comprehensive model and ethical standards to guide an AIS design and suggest that such a model should be employed in AIS design.
Our research objective is supported by an ethical perspective, examining technology's potential aversion and undesirable outcomes, exploring and measuring trust and ethical values for autonomous ground and unmanned aerial vehicles through a moral compass. We hope to influence the Federal Aviation Administration's drone regulations and laws regarding identified autonomous systems.
Our research methods are organized by research questions, literature reviews, analysis, and synthesis of different models and approach to ethics and IAS to develop a more comprehensive ethical
model to guide us in designing increasingly autonomous systems. And that is our study.
Welcome, everyone. Our ARCS research project is on the concept of operations generator for autonomous unmanned vehicles. Our research team is composed of devoted individuals from the ARCS Fellowship, such as myself, to Extensor Systems, who develop next-generation autonomous AI systems, to our amazing CSUN advisors from the Department of Electrical and Computer Engineering. The research objective is to develop a method to autonomously generate mission plans for onboard unmanned aerial vehicle systems in support of intelligence, surveillance, and reconnaissance missions by applying artificial intelligence and machine learning techniques. There are 3 different aims in our research approach. The first is to build an implementable hierarchical software architecture for fully autonomous systems that synthesizes mission planning with sensing, monitoring, fault management, and decision-making. The second aim is to design mission generation algorithms based on the proposed software architecture using fuzzy sets, dynamic programming, and AI-related optimizations. The third aim is to develop a software and hardware toolset that generates an onboard UAV autonomous mission plans following the proposed software architecture. The concept is to provide a smart development station that simulates the target UAV in software and hardware. Specific UAV simulation parameters are contained in the selected UAV platform configuration and payload libraries. Neural nets and interface engines will be used iteratively to create and simulate as many learning repetitions as necessary to optimize mission performance. In conclusion, this project is intended to advance fully autonomous unmanned aerial vehicles operations by providing a scalable mission development environment that generates downloadable mission and concept of operations or CNOPS packages. It also plans to provide a comprehensive UAV autonomy solution that embeds trust, risk capabilities, and detailed contingency plans into autonomous operations. The goal is to further account for human safety in various missions where an unmanned vehicle would provide the greatest mitigation to danger. Thank you for watching.
Hello, my name is Ruby Lynn Lucen, and this study focuses on organizing teamwork, understanding operator and multiple robot team performance. As NASA strives for autonomy through robotics, there comes the demand to strategize ways of communicating with the most robots while using the least amount of human operators. Previous literature states that decentralized communication via directive leadership is most effective for team communication. Under directive leadership, the team follows the direction or priorities of a designated supervisor. The supervisor thus structures a protocol for taking actions and making decisions in the group. Supervisors can also take initiative in presenting new information and encouraging teammates to ask questions about their progress, which is especially productive when teams have similar backgrounds or knowledge. Teams that operate robots use a shared pooled architecture. Unlike sectored architecture, when one team member receives control over a select number of robots, a shared pool architecture has all individuals in the team share control over all the robots. Compared to a group with a sectored architecture, teams with a shared pool architecture communicate more often and have increased productivity through perceivably lesser workload. Therefore, we would like to determine how to synergize both team structures, as well as observe how the effectiveness of decentralized communication translates from human teams to human robot teams. Not only do we want to observe how team structures influence a team's success, but also how the purpose of communication differs between various team structures. In this study, we are focusing on how frequency of task-oriented communication changes according to different team structures. In this study, task-oriented communication is defined as communication that makes explicit reference or is directly related to completing a task. Examples of task-oriented communication include mentioning objects needed to complete a task, explicit instructions, as well as teammate status, such as where a teammate is located, what the teammate perceives in their environment, and status of individual task completion. Our team's research objective is to design a computer-based simulation to test the efficacy of different human-robot team structures. First, we develop a computer-simulated environment with tasks to complete and obstacles to overcome, including collecting stars and completing puzzles to reach the end of the course. Then, we randomly assign participants into 3 different groups. Group 1 uses decentralized communication. One participant is designated as the directive lead of the team and mediates communication between teammates. Teammates will only communicate through the directive lead and not to one another. Group 2 uses centralized or general communication. Teammates are able to freely communicate with one another with no restrictions. Group 3 will have no direct communication. Participants will not directly communicate through text or voice channels. We will then record communication and behaviors and analyze how frequency of task-oriented communication differs between the 2 team structures, as well as how task-oriented communication relates to overall team performance. We hypothesize that the directive lead group will have the higher frequency of task-oriented communication, which will relate to increased task completion and overall higher team performance.
Hi, our project is titled Design and Development of the Proteus Language based on hierarchical state machines for model-based programming. Our research team is made up of fellows and associates. Katie and I are fellows on this project, and our project is done in collaboration with Dr. Michael Ingham and Dr. Klaus Havland from JPL. Our CSUN advisor is Professor Cal Dewey. So, why is our research focused on the development of Proteus? NASA JPL space software is developed using hierarchical state machines, but the languages currently utilized are not especially suited to their needs. Our research intends to develop a language that is compatible with the current software and is tailored to NASA's JPL's specific needs as outlined by their engineers. This project is applicable to any NASA JPL space software, which plans to expand to simulation software. If we look at these 2 images, we can see a direct comparison between the source code of a state machine and the diagram of what the code is going through. We initially start at state S1 and wait for an event to occur. Once event 1 occurs, we then proceed to state S2, where we start on state S21. Event 1 then proceeds to state S22, and once we are on state S22, we loop back to state S21 and exit state S2 and go back to S1, which then the process waits for another event to occur.
Our research objective is in space applications, software correctness is highly important because individuals are rarely present in space to fix those issues that might occur within the system, such as lacking memory space, bugs, or component failures. To address these concerns, we are developing a new hierarchical state machine for model-based programming called Proteus. Our research approach is Proteus is designed with a look and feel similar to C and C++, making it usable and approachable for JPL software engineers. We will continue to gather information via correspondence with current NASA and JPL engineers. Upon their feedback, we will determine which features are essential to implement in the Proteus language and compiler. The Proteus language will be implemented incrementally and will grow through the addition of features. This concludes our presentation on the design and development of the Proteus language based on hierarchical state machines for model-based programming.
Hello everyone, I'm Mrinal.
And I'm Isis.
And our project is titled Autonomy Law, particularly dealing with applying computational methods like artificial intelligence for legal analytics. Our research team consists of 2 ARCS fellows, and our principal investigator is Dr. Gadisi, as seen on the poster. This project investigates and highlights the impacts of artificial intelligence on legal decision making. It proposes the ways in which autonomy law can be achieved through advanced artificial intelligence and the ways in which it can impact individuals and society.
And more broadly, the envisioned outcomes of the Autonomy in Law project have prolific synergy to bring legal understanding and legal tools to everyone in society, thus enhancing access to justice and improving the legal system as a whole. And this project makes CSUN one of the very few institutions that provides novel research and insights in the area of autonomy and law.
We are currently working on 2 research projects together.
One of our research projects is to analyze California contract cases using a Harvard case law database and AWS AI services to examine trends and shed lights on multiple fronts, including the parties involved and the court's reasonings.
And the other research project we are working on deals with applying cutting-edge bidirectional encoder representations from Transformers algorithm BERT and comparing it with variability indices to predict companies' responses to consumer complaints from Consumer Financial Protection Bureau database.
So for our projects, some of the research methods that we are using is to apply cutting-edge natural language processing, or NLP, techniques in law to computationally analyze the historical trends of case law development in California and other jurisdictions as well.
Furthermore, we also developed custom named entity recognition on legal case names using AWS AI services to extract individual organizations and their corresponding roles.
And in addition, we've also analyzed NLP applicability to predict organizational responses to consumer legal complaints, again using the Consumer Financial Protection Bureau database.
We also applied the state-of-the-art bidirectional encoder representations on Transformers BERT algorithm
to consumer complaints for variability assessments, enabling prediction of organizational responses. Thank you. That's it for our project.
Welcome to the Workers in Technology Together presentation, also known as WAT. My name is Kiana Samoy, and I am an undergraduate researcher studying business analytics. Our transdisciplinary team consists of engineers, designers, and entrepreneurs. David will go into more detail about the problem facing the waste management industry.
Hello, my name is David Bell, and I'm a master's student in manufacturing systems engineering. Currently, a problem in the organic waste processing industry is there is a high reliance on low-skill labor with little automation in use. With the implementation of new technology to help identify and sort input materials, we can reskill and upskill the current labor force and create a more efficient and safe work environment and help divert more waste from landfills, creating a positive environmental impact. The flowchart in our poster has green arrows to show the current process and the red arrows to show how we're going to fix the problem. Mitesh will discuss our research objectives on our project next.
Hello, I'm Mitesh Sawant. I'm a master's student in engineering management. BOT is creating autonomous assistants to work alongside workers, owners, and operators in the organic waste processing industry. The objective is to implement automation technology and upskill the workers to work in conjunction with the digital twin. Jin Hao will continue with the research approach.
Hi, this is Jian Hao. I'm an undergraduate student in mechanical engineering. Produce differentiation module based on local operation context to determine worker responsibility, automatic tasks, and essential. We will consider using the digital twin and the AI technology with object detection technology to sort the garbage. We have done a lot of projects with digital twin, so we are pretty confident about that. And for HEMA, we will continue on the object detection part.
Let's dive into the current status of the WAT project. I'm Fahima Arif, and I'm a graduate researcher currently pursuing my master's in electrical engineering. Object detection is an integral part of the WAT project. The initial tests that we ran have an accuracy of about 85%, with some systems having a whopping accuracy of about 98%. Nitya will now continue more about the business and legal aspects.
Hi, my name is Nitya and I'm an MBA student. So we are preparing for the interviews currently, and so we have submitted the IRB proposal and simultaneously working on the questions that will be asked to the workers. We are doing this because it's workers and technology together, and we want to keep the environment best, keeping the social, behavioral, and legal aspects in mind as well. Next up is Joshua with his part with art aspects of WAT.
My name is Joshua Vasquez, and I'm an undergrad student earning my degree in visual communication. While we are conducting interviews during various site visits, not only are we trying to have a better understanding for the site's processes and workflow, we also seek opportunities that may arise in areas of improvement and where we may be able to implement AI technology.
Thank you for listening to the Workers in Technology Together presentation. Have a wonderful day, and don't forget to dispose of your waste in the proper bin.